Hello, welcome to channel Sube. Children, today I am going to discuss question number 47 from the MCQ part of 2019 Physics New Syllabus paper. Consider the circuit shown in the figure. The graphs show the waveforms of the applied voltage and the current through the load L. So this one is the load. So between these terminals we give a voltage like this and a current like this. So the variation of voltage is shown in this graph like that. With the time it goes to positive, it goes to negative, again goes to positive, like that is a variation. So here also the current supplied to these terminals like that, so it flows through this load. The current is also like this, change from positive to negative, again 0, stay at 0 a certain time, then goes to positive, so like that it changes. So let us see what they want us to find out. The average power dissipation of the load is the average power. What is the power? What is the meaning of power? If we say power is the work done per unit time. So that is called power. So the units are joule per second, or in other words watt, 100 watt, 200 watt, like that we can say. So that is what power. But what is the equation that we can use to calculate the power? You should remember that in current electricity, the lesson current electricity, we use this equation: power equals voltage time current, VI. The multiplication of VI is called power. So we have to find out power like this. But there are other equations. This one is the basic equation. So there are some several equations. P equals I squared R. If we know the resistance and current, we can find the power in that way also, because this one is called Joule's equation, because Joule found that power is proportional to I squared and to R. Therefore this equation is Joule's equation. And using V equals IR, that's Ohm's equation, we can isolate I and substitute to this I squared after taking the square value of that. Then we can receive another equation, P equals V squared by R. This one also a formula that we can use. But here in this question we can't use this, because we don't know the resistance, the load. Only they have said load, but we don't know the resistance of that load. Therefore this one we don't know, here this one we don't know. Therefore we can't use these equations. Since we know at least the variation, the graphs of V and I, we can try to use this and solve this question. But the problem is the voltage is not constant. We can't use this value because it is not constant all the time. It changes after T/2 time. So the current also, this V max, we can't use this value because it also changes with the time. So in this equation these values must be constant. That means we have to take a value from a graph. If we have given a graph, a constant value like this. If the value is like this, we can use, no problem. The current also same. But the problem here is they are changing. So we have to find out a constant value constant value. It may be located somewhere, we don't know, here or here or somewhere. Also we have to find out a constant current instead of this varying current. Somewhere it might locate somewhere, so we have to, however, find out it. So let us try to find that constant value, because we need then to substitute to this equation. We can't substitute to this equation a varying value. Therefore let us try to do it first. So children, first of all let us talk about this power. This power is always a positive value. It never get a negative value. So imagine when we substitute this voltage, the voltage can be either positive or negative. But here the power must be positive. The current also may be either positive or negative. But if we applied negative current here and positive voltage, what happens? The power becomes negative. Positive, negative, when we multiply, we get a negative result. But it can't be. Therefore, we must get positive values for this voltage and positive values for this current. That means the direction doesn't influence the power. The direction of the voltage, either positive or negative. What is the meaning of this positive and negative? The voltage, the direction of the voltage. If this voltage is positive and this voltage is negative, we say this terminal is higher than this terminal. So that means the current flows this way. And if we say negative voltage, so this terminal is negative, this one is positive, then current flows this way. So the meaning of this positive and negative is not something else other than just the direction of this current, this way or this way, and voltage. Voltage drives the current. So let us talk about this current then. The direction of current is here denoted by positive and negative. So the direction of the current doesn't influence the power. Power means work done per unit time. Work, because work has no direction. It is a scalar. It is not a what we called vector. It is not a vector. Therefore, imagine, so I can explain it a little bit more. Imagine this one, you know, what is this? This is called electric hot plate that we use to cook. So the current might flow this way or sometimes this way. We don't know. If it is an alternative current like this, with the time it changes the direction. For a moment the direction is this way. Next moment the direction is this way. Like that, very rapidly the direction of the current flow changes. But the power dissipation is constant. It doesn't change. It doesn't once dissipate and once absorb. It never absorbs. So therefore we must know the power is always positive and has no direction. The voltage, the direction of the voltage or the direction of the current doesn't influence. Therefore these negative values of voltage are meaningless. We can convert them to positive values like this. We can invert these waves to positive side. Also we can invert this current. The wave pattern we can convert to positive side, because negative values are useless, because either positive or negative doesn't matter. We have to get the magnitude only the magnitude. We denote by this, you know, we denote by this I magnitude, voltage magnitude, only the magnitude. Direction is useless. Therefore we can do what? We can convert these negative parts or invert them like this. I'll show you to positive. Using this computer I can easily do it. Flip like this. We can alter this graph a little bit, because these negative values we don't want. So like this. So we can use this graph instead of the previous one. No problem. No problem. It doesn't affect the final result. Therefore, now we have received a constant value. The voltage is constant at this level. You see, constant at this level. Vm. We don't know what is the meaning of this Vm. Maximum maybe. So, however, it is the constant voltage, because how does it change now? Earlier, previously it changed like this, rise up and fall down like this, and went to negative side and like this. But now it rises up and it stays like this, and again it stays like this, and again it stays like this. So constant. It never goes to negative side. Practically it goes, but it doesn't matter here, because only what we need is the magnitude. Only the magnitude we need. Only the magnitude we need. Therefore, we can convert all the negative values to positive. So now we know what is the constant voltage. What is it? We can use this value. So the same way we can convert this current, the negative current, to positive. I can do it like this using this triangle. Let us try to do this. First of all, I have to turn it to match the graph like this, upside down, no, left, right, like this. So this is the I can change the color so that you can easily see it. So I'm going to do what, to flip this so that it will appear at the positive side, because negative values we don't want. So this part, this portion of this graph, we can take to up portion, the positive side. So how to do it? We can move it here and place here. Already there is a positive value here. This one is already positive. So this negative value we can move and place here. So now we can delete this one, because this one we have taken to the positive side. So now this one is the variation. Now we can imagine. So this is how the current is flowing in this load, like this, constant for a little time, and goes down. So stays at 0. So like that. Now we have to limit the time, because this goes to infinity. Let us limit the time here, so that the time is capital T. Capital T means, so this capital T is here, the same must be here, capital T, because it is being deleted, because I moved that part up to the positive side. Therefore it has been deleted. So there was this value, capital T value, in this x-axis. So this place is capital T, that is the period. So here it is still there. So this place. So what we are going to do? We are going to limit the time up to capital T. If we consider that part, that is enough. So now our graph is like this. So we don't have to consider this beyond that capital T. This enough. and also this red color line now we don't want, so I delete it. Now the graph is like that. Why did it change to this shape? Because we took this pattern upwards and placed it here. So now totally this one is the shape. This one is the shape. Now you see here blank, here also blank, only this part is filled. Now we can do this. Now we can do this. We can divide this to four parts. First divide, because 1, 2, 3, 4, there are four parts here in the time axis. T by 4, T by 2, then 3/4 here, then T. So we have to divide this area, we have to give share to these parts, because they have no current, zero, they have zero. So we want what? To get constant. Constant means everybody must have current. Therefore we are going to share this square to those other time parts. So this one we are going to divide into four parts, like this. First I divide it to 2, approximately half, then again quarter, like this. Now there are four parts, so I cut quarter of this I maximum, quarter of this I maximum. The total height is I maximum. I divided it into four parts, so one is I maximum divided by 4. So I place it here. So now you have current. So I have to take the total one. So here I place, then I take this quarter and give to this time portion, and I take this quarter and give to this time portion. Now you see, what we want is this constant current. So every time parts now has a current. This one has this value, this one has this value, this one has this value. So now constant. Now the current is constant. What is the value here? I maximum divided by 4. Here it is constant. The value is I maximum divided by 4. Already we have done this one, V maximum. So now we know the constant values, both of these variables. So we can substitute. Instead of V, we can write V, same. Then multiply by this one, I m divided by 4. I m divided by 4. So this is the result we get for power. That means this is the answer. So here you see the answer, Vm times Im divided by 4. So children, the answer is second one. I think it is clear. I explained. You have to divide this varying current or voltage in between all these time parts, so that it gets a level value, constant value, without moving here and there like that. The values for each time parts means T divided by, so when we plot the graph like this, first T divided by 4, then the time portion T divided by 2, then 3/4 of T, then finally T. So all these time parts must have a same value like this, same value. like this same value. So they, until they get that same value, we have to divide this varying value in between these time portions. So like that. Now we have done it. I think it is clear to you. So I think you understood. I think you are happy. So I think you will subscribe my channel, therefore watch again and again. So see you tomorrow. Goodbye.